Quick reminder for me. When we did Hill SAS on Monday, Tuesday, what type of triangle did we need? Right triangles. Still the case today to what I'm about to show you. We are still working with a right triangle. Special ones, though. 2 special right triangles. First thing, I'd like to see what you guys can do here. Can you please make me an isosceles right triangle with the correct angle markings and side markings in it for me? Okay. At the top of that page, can you make a quick sketch of an isosceles right triangle with correct angle marks and side markings? That tells me it's isosceles and tells me it's a right triangle. Oh, look good. Some of you putting in some more. Okay. Putting in some more markings. I like it. All right, I got a lot of that. Putting the legs congruent. And then some of you even took it a step further, saying if it's isosceles, what do you know about the angles across from those sides? Congruent. I'm going to ask for a little bit more detail than just those markings. I'd actually like to know what the degree measure is for me, please. Don't say a word, just think about it. What are the degree measures of those 2 congruent angles? Okay. Crunch some numbers if you have to real quick. Emma, what do you have? 45, everyone agree? 45 degrees. I'd like to welcome you to your first special right triangle today. 45, 45, 90. That's what it's called. All right? 45, 45, 90. There are special relationships between the sides. And you're about to find those out right now. Everyone has 6 examples down below. They're all isosceles right triangles, where angle B is the right angle. And I want to find the remaining 2 sides. And as we do these, you're going to start seeing a pattern between the legs and the hypotenuse. So let's start with the first one here, where BC is 1. Everyone knows these angles are congruent, which means the sides across are also congruent. So what's the value of segment AB? Also 1. No big deal. We know those sides are congruent. Can you find me the hypotenuse? Come on. Find me the hypotenuse. How? How? We're not going to guess. Pythag, it's a right triangle. Go ahead. I'll give you a second. Pythagorean theorem to find the hypotenuse, and make sure you keep it in simplest radical form. Hypotenuse length. What do you got? Number 7. What do you have? Radical 2. All right. I can't find a pattern with one example. Let's keep going. Next one. Now the side length's 2. What's the other side? What's the other leg? 2. No big deal. We know that. Hypotenuse. Go ahead. In simplest radical form. So if you're giving me radical 8, I need it simplified. Hypotenuse length. 1, what do you have? 2, radical 2. Maybe we start seeing a pattern. Let's just confirm it and go to B being 3 now. What's AB going to still be? 3. Okay, go ahead and do Pythag, simplest radical form, just to confirm our patterns here. Don't go on to the other 3. Just stick with side length of 3. And what are you noticing for AC on this triangle? 9? 3 radical 2. Nice job. See a pattern now? Okay. Let's see if we can apply it here without using any Pythagorean theorem. So I have a 45, 45, 90 triangle. The 2 legs are always going to be equal, so this will be 4 without doing any Pythag. What do I need to do to the leg to get to the hypotenuse? Look, 1, 1 radical 2. 2, 2 radical 2. 3, 3 radical 2. So this will be, you're multiplying the leg by radical 2. So over here, this will be 5 and 5 radical 2, 6. Okay, you guys found the pattern for a 45, 45, 90. Now let's write it as a conclusion. And I'm not going to write out a bunch of words or theorems here. When we do these special right triangles, we are going to use a chart. What's the chart have in it? 45, 45, and 90, the degree measures of the triangle. What you guys will start putting underneath are the side lengths across from those angles. What do you guys know about the sides across from the two 45-degree measures? They're always the same. So in general, I'm just going to put X and X. I always know they're the same. They will actually be values when we start doing examples. It will be 9 and 9, radical 5 and radical 5. What must you do to that side, either side, to get to the hypotenuse, the side across from the 90? So what do you think is going to go in here now? X, radical 2. Perfect. These are the tables we'll start filling in. Questions on the patterns before we actually put numbers to them now. All right? I just want you guys to be aware that numbers 1 and 2 both go to the same diagram. So if you want to redraw it, erase it, it's your call. All right? It's a right triangle. And in number 1, I'm telling you that A is 45. So right off the bat, I know I'm dealing with a special right triangle. In this case, what is it? It's a 45, 45, 90. Because I'm going to introduce you to a second special one in a minute. But this one, 45, 45, 90. BC, 18. Find the other two sides. Now, hey, I know you can do this without busting out my chart I just showed you. But I want you to be used to applying it. Because starting tomorrow, those numbers aren't going to be as neat as 18. So X, X, and what was across from the 90? X radical 2. Here's how you use my chart. Everyone see 18. What angle is it across from? A 45. So that's where it's going to go in my chart. It's going to go under a 45. Can you fill out the rest? What's across from the other 45? Also 18. And what do I do with the 18 to get to the side across from 90? What's the rule say? Multiply it by radical 2. So now I just have to, so AB, where was AB? Across from? AB was across from the what angle? The 90, what did we say was across from the 90? 18 radical 2. And where was AC? AC was across from one of the 45, so that's going to be 18. All right, see how this is working. Okay, let's go a little bit more. Now I'm not going to give you the 45, I'm going to give you the side across from 90. So take a look. Now AB, 17 radical 2. A little different. I gave you the hypotenuse. So again, I'm going to set up my chart because I know it's a 45, 45, 90. X, X, X radical 2. Where's the 17 radical 2 across from? What angle measure is the 17 radical 2 across from? Here you go. Let's hear from 13. Never mind. I think I would know that by now. 1. Sure. Where's the 17 radical 2 across from? What angle measure, Cam? Which is the 90. So in my chart, it's going to go right here across under the 90. Ooh, everyone see we're going backwards now. We're going backwards. What must have been the value of X here for me if I had 17 radical 2? 17. So both the sides across from the 45 are 17 and 17. So AC and BC are both equal 17. Take a breath. Anything you want to ask about this special one, because the next one's a little bit more involved. The next special right triangle I show you. Questions, comments, any concerns? Everyone see the patterns here? X, X, and then multiply by radical 2. You don't have to. I'm not asking you, but tomorrow when we start, Amy, here's the problem tomorrow. Like I gave you 17 radical 2 and it was very easy, just take away the radical 2. But tomorrow I'm going to give you 17 radical 3. And what do I do then? I can't just take, yeah, I know. Make sure you're here for that. All right. So that's why I'm just, today, no, it's probably not needed, but I think it'll be helpful if you know how to use it starting tomorrow. Other questions? All right, next one, next triangle. Let's see if you can figure out the name of the next one. Equilateral, what do you know about it? Just let's go, throw some stuff out. All sides equal, yep. Give me more, need more. Okay, all angles equal, build off that, build off it. All angles equal, which means all angles equal 60 degrees. Just keep feeding your face, all right? 60 degrees, okay? 60 degrees. That's what I expected out of you. All sides are equal, all angles are 60 degrees. Okay, I got two theorems in there for you. What I'd like you to do is draw an angle bisector from this top angle down. Draw an angle bisector for me. Two things now. If I know that's an angle bisector and the triangle's equilateral, an angle bisector is also an altitude. Meaning what to you guys? Forms A? Right angles, right? Not only is it an altitude, any guesses? It's also a median, all right? An angle bisector is also a median in an equilateral triangle. So if I'm told it's an angle bisector, boom, I know it's also an altitude and a median. All right, let's go back to the triangle. If it's an angle bisector, what are these two angles going to be? 30 and 30, nice. You've already identified my next special right triangle, which is called a 30, 60, 90. Okay, we had 45, 45, 90. Now we have a 30, 60, 90. What's so special about the sides? Let's find out. You have three triangles right now to find out what's so special about a 30, 60, 90. Okay, let's start with the triangle that has AB equal to 2. Notice what I told you above. They're all equilateral. So somebody tell me what's angle A. Angle A, 60. And BD is a bisector, meaning it's also a altitude and a median. Remember that. Remember that. If it's an altitude, what do I have at angle BDA? 90 degrees. That must mean angle ABD, the remaining one up here, is 30. Perfect. Let's talk. What did I give you? The side across from the... What did I give you here? 2? Where's that across from? What angle measurement? The 90. All right, can you help me find the other two sides of triangle ADB? This triangle only. You can do it. What type of triangle was it? Equilateral, all sides equal, right? And BD is not only an altitude, but it's also a median. Where do medians go to? Midpoints. So what is the length of AD then? 1. Nice. 1. I can't tell you off the top of my head what BD is, but do we have a method to find it? Go, Pythag, yes. Pythag. Make sure you realize that BD is a leg, not a hypotenuse when you're filling in that Pythagorean theorem. Good. Good. We're getting it. Perfect. What do you have as BD now? BD? 11? Oh, excuse me? A negative underneath the radical since when? Radical 3. Because you had 4, you brought over the 1. right? 1 squared equals b squared equals 2 squared, right? 1 squared plus b squared equals 2 squared. Everyone's all right? Okay, no way we're finding a pattern yet. Let's go to the next one. Now we go from a length of 2 to a length of 4. Same setup. So there's my 60. There's my 30. Ready? What should be the length of AD now? AD. Woo, 14. 2. Half of that side of 4. Perfect. Go ahead, Pythag. Simplest radical form, of course, so we can see the pattern. Maybe you start seeing it now. We'll confirm it on the third one. $18. We find it? 3, 3. 2 radical 3. Got it. Seeing a little pattern now? How to find the sides? Okay, well, let's confirm it. Last one. There's 60. There's 30. Automatically, what's AD going to be? 3. We know that for sure. Quick Pythag. Go ahead. Quick Pythag. What are we predicting it's going to be? Predictions. Okay, let's maybe 3 radical 3. Go ahead. Confirm it. You breaking down square root of 27? What's 27 break down into? 3 radical 3. Nice. So now we see the pattern. Let's put it into a chart. 30, 60, 90. Let's see if we really understand the pattern now. I will fill it in first. I'll tell you the side across from 30 we don't know. That's x. What do I have to do to that side to get to the side across from 60? What do I have to do to that side to get to the side across from 90? Look at all 3 triangles. Look at all 3 triangles. What did I have to do to that side across from 30? Ready? What did I have to do to 2 to get to 2 radical 3? To 3 to get to 3 radical 3. What do I need to do? 5. What do I need to do? So what should go in here? X radical 3. What do I do to that side to get to the hypotenuse across from the 90? 1 to 2, 2 to 4, 3 to 6. What am I doing to that side? 10, what am I doing? 2, so what should here, Luke? I'm taking that side and multiplying it by 2. So, you got it. Yeah, be confident. You got it. All right, we got it. Okay, you're all rookies right now doing this. So I will let you know a potential pitfall you may unfortunately fall into. The 45, 45, 90 involved radical what? 2. This involves radical. Don't mix them up. Okay, classic mistake. All right, classic. Don't mix them up. The radical 3 belongs to the 30, 60, 90. The radical 2 belongs to the 45, 45, 90. Anything you want to ask, because now we're going hardcore, mixing it all together now. Questions, comments? All right, let's see what you got. Let's see what you're made of. I apologize. I only gave you 1 diagram for 4 questions. All right, so you can erase, cross out. Yep, it goes on to the next page. Okay. Sorry, I provided 2. I must have been had a heart that day. Oh, okay. It's a right triangle. Angle A, 45 degrees in this first one. So you're thinking about what rules now? What triangle? 45, 45, 90. BC, 11, radical 2. Uh-oh. Woo. Find AB. All right. No need to panic. Ready? Let's get the chart out. 45, 45, 90. What's the rules? X, and? Okay, all right. Take your time. What side did I give you? 1 across from the, okay, so put it in one of the 45 columns, 11 radical 2. So what's even though I know I didn't ask it, but I just want you to get used to filling out the chart. What's across from the other 45 then? 11 radical 2. All right, everyone ready, focused in. What do you need to do to this side to get to the side across from 90, which I'm asking for? Multiply it by radical 2. So I'm going to take 11 radical 2 and multiply it by, what's the rule? Radical 2. Now we got to review a little algebra from last year. But is everyone all right? Cam, go. No. What's the rule? Take that side and multiply it by radical 2. We're all right? Everyone else, we okay? Go ahead. Anything else?
Wait, so that x is counted?
That's the side across from 45. X.
That's x.
Yes.
But if you're multiplying it by x square root of 2,
Well, what's x? What's x though? X is 11 radical 2, right?
Yeah.
And I'm taking that. Ready? Okay. No. That is x.
Oh, I see.
Good? So I'm just multiplying it by radical 2. All right, last year, anybody remember what happened when you multiplied a radical by itself? Woo. It becomes the number underneath. Radical 2 times radical 2 is 2. Okay, hey, here you go. No big deal. The radicals do, yeah. Because look, hey, this is what, ready? What's 2 times 2? What's the square root of 4? That's how it comes out. Okay, that's what's happening there. That's what's happening, all right? So now, that's going to be what? 11 times, what did we just find out? 2. So what's the side across from the 90? 22. Okay? Questions? Okay, I don't know if we're going to get through all, because I want to get through that. I want to get to that very last one too. All right, with the double triangles. So let's do the next one. So now I'm turning angle A into 30 degrees. And BC now is 18. What type of triangle am I working with now? 30-60. So new rules, new chart. What were my rules on the 30-60? X under the 30, x radical 3 for the 60, and 2x. What side did I give you? The one across from the 30. So that's where the 18 is going to go. The 18 in my chart is going to go into the 30. Help me fill in the rest of the chart so I can answer the question. What's going to be across from the 60 then? X, what's the value of x? 18 times radical 3. So it's going to be 18 radical 3. How do I find out what's across from the 90? What's x? So 18 times 2? 36. We okay there? All right, so go back. We didn't finish the question, though. AB. Where was AB? That was across from the 90. What did we put across from the 90 in our chart? 36. And then AC was across from the, what degree measure? 60. What did we put? 60 was 18 radical 3. We okay? If we have time here, we'll go back to 3 and 4, but I want to make sure we get to the double triangle one so you don't get freaked out tonight on the homework. Anything you want to ask? All right, let's go to that double triangle one. Finish this off strong. Fill in the angle measurements that's given. Go ahead, fill in all the angle measurements. BCA is a 90-degree angle. BDC, find that angle, is 45. And BAC is 30. Whew, and find 4 different measurements. Yeah, Cam, go ahead.
So like when you say like B is a point on AC,
Yep.
like how are you supposed to ever use that? Like what does that show?
Well, they're telling you that they got to put D on there for the angle, because if see how they gave you angle BDC?
Yeah.
If D's not on there, then
Oh, so
it's not an angle. It's just floating in there, okay? Good question. All right, first thing I would try out, hey, how about filling in all the rest of the angle measurements in that diagram? Okay, fill out the rest of them. Remember, there's 180 degrees in a triangle. Linear pairs are supplementary. Fill in the rest of the angle measurements. What's the one next to the 45? The one next to the 45? 135. How about angle CBD, this one right up here? That's 45. And I'm missing one more, the one next to the 45. Should be 15 degrees. Is everyone all set? Filling them in. Okay, my next question. How many of you see a 45, 45, 90 triangle in my diagram? How many of you see a 45, 45? How many? Hugh, name it. Okay, so triangle BCD, and I'm just writing this down so we remember, you don't have to, 45, 45, 90. Anybody see a 30, 60, 90 in my diagram? Anybody see a 30, 60, 90 triangle in that diagram? Evan, name it. ABC, the big dog, right? Nice job. Oh, I forgot to label BC's 10, right? That's going to be pretty helpful. All right, we ready? What triangle do you want to start with? Because we could start with any of them, the 45 or the 30? 45, you got it. So everyone take a look at BCD. 45, 45, 90. What are my rules? X squared. X radical 2. Ready? Guys, you can only use this triangle. Don't look at any other sides except for those. What side did I give you? Where's it across from? All right. So guess where it's going? Boom. 10. What's across from the other 45? They're both the same, right? That was the big thing you told me at the beginning. So across from the other 45 is 10. Name the side that's across from the other 45. What's the side in this triangle? In triangle BCD, what's the side across from the other 45? CD, right? So CD is 10, and that's one of them we needed to find. Perfect. What's across from the 90-degree angle then in this triangle? What's the side length? I got 10, and it's x radical 2. 10 radical 2. Name the segment that's 10 radical 2 in the 45, 45, 90. Right here, DB, which is another one we needed to find. Everyone see how we're rolling along? Questions on the 45, 45 before we finish this off on the 30, 60? Are you ready for the 30, 60? Again, what triangle was the 30, 60, 90? It was triangle, the whole one. So again, only look at the whole triangle. I don't care about DB. It's just there to fool with your mind. Look at the sides in triangle ABC. Help me out first. X radical 3n 2x. Okay, again, where's that 10 now? It's not across from the 45. I'm in a different triangle now. It's across from the 30. So what's the side across from 60's length going to be? Look at the rule. What do I do? 10 radical 3. Name that side. In triangle ABC, name that side. That side is across. Here's the 60. What's the side across? CA. Yep. We're down to one more. Finish. We all right? Why is this so painful? Sorry. I'm not yelling. I'm just trying to make a point here. Sorry. Yes. Okay. The 20. Name the segment across from the 20. That would be segment AB. That is an excellent job by all of you. Way to go. I cannot wait until tomorrow's class. Are there any questions you would like me to answer as your teacher? Then we will keep it as that. It's so much worse.